What's up, scholars? Today we're talking about scalar multiplication of vectors. Talked a lot about vectors last time, so we're going to just jump right into some delightful examples. All right, this question says, given vector v, that's this guy here, is 6, -6. That makes sense because it goes to the right 6 and down 6. Find 1.5 times v graphically by stretching the vector by its tip and then writing the resultant in component form. Okay, so this means we're going to literally stretch the vector by its tip and get the resultant in component form. This is 1.5 times v, which means both of these components are going to get multiplied by 1.5. So 1.5 v. It's going to mean both of these components are multiplied by 1.5 times 6 and 1.5 times -6. We're multiplying both of these components by 1.5. 1.5 times 6 is 9. And 1.5 times, oops, I wrote down -9 because I was excited because I knew what the answer was. 1.5 times -6 is -9. So our new vector, 1.5 times our old vector, is 9, -9. So if I stretch this guy to 9, -9, that's 1.5 times our original vector. And that's literally it. You have now multiplied a vector by 1.5, stretching it graphically, et voila, there's our resultant vector. Yeah, sorry guys, this is supposed to be a comma right here. So 1.5 times 6. I'm trying to, and doing a poor job here of writing this out using my drawing tools. So 1.5 times 6, comma, 1.5 times -6, getting our resultant vector, 9, -9. So we put our answer at 9, -9, press submit, tell the math and you're like, are you sure? We'll be like, yes. Why? Because we're geniuses. Ta-da! Okay, next one, same idea. Given a vector v is equal to -4, 2, it says find -2.5 times v. Now this time we're not drawing it, we're just finding it algebraically. Not as interesting, admittedly. Kind of more fun to see the picture, but we're literally just going to take -2.5 times each of these components. This is going to equal, let's see if I can draw better this time. I think I can. -2.5 times -4, comma, -2.5 times +4. These have been pretty pleasant so far because we're multiplying by the same number. So once we figure out the first one, we just change the sign of the second one. -2.5 times 4. What is that? 2 times 4 would be 8, and 1/2 times 4 would be 2. So yeah, 10. -2.5 times -4 is +10. And -2.5 times +4 is going to be -10. Easy peasy, lemon squeezy. If we flipped them, would they be the same? In the answer? Nope, they got to be in this order. Yep. 10, -10, submit. Are you sure? Yes, we are. All right, last topic, combining scalar multiples of vectors graphically. Okay, it says given vector u is -3, -1. I see you down there, right there. Given, I say, vector u is at 3, -1. So there's little tiny vector u, 3, -1. And vector v is 3, -3. So there's vector v at 3, -3. Determine the value of 2u minus b. So we're going to combine what we're talking about now with what we talked about last time with our subtraction here. It says click and drag the dotted vectors as many times as you need using the tip to tail method in order to find the result graphically. You may have to negate the direction of one of these vectors by pressing the whoop link. Which one of these vectors are going to need to be negative? V, yeah, we're subtracting V. So when we start using the V here, we're going to need to negate the V. So I want 2 times U. Let's see, let's take this guy and drag another one. So there's 2 U's. And the nice thing about this is if I misplace it a little bit, it'll snap it to right where it's supposed to go. So we did 2 U's. And then we need a negative V. So we're going to negate V. There it goes. And I'm going to move that V to the tip of where I left off. There we go. So again, I just want you to see if I put it off a little bit, it will snap it to where it needs to go. So we've got 2 U's and we subtracted V. 2U minus V. Questions there?
That's it.
That's it. And then we're supposed to have the result, which means we need to start where we started and end where we ended. Right? Okay, so we can't actually draw the result, but we can see the result. If we would start here, start where we started, and end where we ended, we went over 3 and up 1. Over 3 and up 1. So again, the direction said we wanted 2U minus V, so we made 2 U's. We negated V, so we could add a negative V to the tip of our 2U, and our resultant starts where we started and ends where we ended with a 3, 1. So let's plug that in here. 3, 1, submit. Are you sure? Yes. Kapow! All right, scholars, that's it. That is your scalar multiplication of vectors. Have a good time. Love you so much. Keep on that hustle, and we'll see ya.